Okay, and here you see the original hub I made, and you notice that the teeth, the rows of teeth are just parallel cuts. Now we're going to go ahead and make that spiral cut hub. Okay, and here, just as I did before, I prepared a piece of 1/2-inch drill rod stock, and I machined the end down so that it's below the diameter of the bottom of the resulting teeth that I'm going to cut ultimately, as well as this area here where the cutter which will allow the cutter to emerge as we are threading it. Now this is a basic threading operation, and I assume most of you know how to do that, so I will not go into all of the very detailed information about threading on the lathe. But basically I have set the lathe to thread a 10 pitch thread, in other words 10 threads per inch. Now on the previous hub we used our indicator, this time we will not have to. And I did take already a very light pass across, and you see the concentric grooves that were created. Very light, it's just a little scratch job at this point. Now I'm going to check that with my thread gauge to make sure it is indeed 10 pitch. Okay, let's go ahead and check this. And as you can see, the points of my 10 pitch thread gauge fit perfectly. Okay, now for those of you who have done a little bit of threading but are not quite familiar with it, basically the way this works is I have set the lathe gear train with that little 25 tooth gear that I made previously, so that it gives me a 10 pitch advance rate. In other words, each thread is located at 100 thousandths of an inch apart, so that gives me 10 threads per inch. Now I have the cutter perpendicular to the side of the material I'm going to thread. I have brought my cutter so that it just kisses the surface of the material, and then I have set my cross slide dial at 0, and I've done the same thing with the compound slide dial. That's also set at 0. Now the compound slide is set at 20 degrees to the workpiece, which is half of the included angle of the cutter, which is 40. Now normally when you thread you would use a threading dial, but in this case I'm just going to leave the half nuts engaged, and when I make my pass across the workpiece, that will once it clears, as you can see in this little area, the recess, then I will stop the lathe and then retract the cross slide to clear the cutter away from the work. Advance my carriage to the right with the lead screw handle that I have installed, and then set the cross slide back to 0. It gets kind of the different things you have to do get kind of confusing, but once you get used to it, they come automatic. And then advance the cutter into the work another 3 thousandths with the compound, and so on and so on and so on until we have reached the proper depth, which is 67 thousandths of an inch. Okay, so let's begin. This gets a little bit tricky because I have the half nuts always locked. So what we do is turn it off and then retract the work, and with the handle move the carriage by hand back. Now if this lathe originally had a reversing motion with a reversing switch, which made that function very simple to accomplish, but unfortunately when I took the motor off, I was not able to reverse the present motor because it has brushes that are mounted on a slant, and that does not allow a reversing function. This is a very heavy cut, as you can see. It's having trouble. I have set my belt for a bit of a belt slip in case I get into trouble with a catch that would not burn out the motor. So in a cut such as this, which is a 40-degree square tip cutter, wow, that's a lot of power, and I just don't think this lathe has that much power, but it does get the job done. It just takes a lot of patience. And slowly but surely, hopefully, we'll get this job done. And you can see that the grooves are being delineated more and more, and ultimately they should be cut to the full depth. Let me back it up so I can get a good head start. You just got to make sure you stop it at that recess. Normally you would just disengage the half nuts at that point. Okay, on a real expensive lathe, a regular lathe, not this little unit that I have, you would probably have no trouble cutting this thread. But this is the idea. You're going to go ahead and continue until you have cut it to full depth, which is, remember, 67 to 70 thousandths. You could go a little bit deeper. It really doesn't matter for this. What's important is the spacing between the peaks of these grooves. It has to be about, I'd say about 33 thousandths of an inch or something like that. And that's something that you can use a gauge against it, like a feeler gauge, to check against, because it's a little bit hard to measure. Okay, at this time I have reached a depth of about 69 thousandths, and we'll bottom out at 70 thousandths just to have a little extra clearance at the bottom. And that was just taking off a little dust. Okay, now we'll move the carriage out of the way. I'm going to clean up some of this mess and come back, and we'll begin to do that little rounding off operation on top of the square portion of the groove. Okay, and there you can see the now cleaned up spiral groove. And we'll go ahead and start it. And I'm going to get my little triangular file and proceed to do the same operation I did on the previous hob. Just very lightly. File all the way across. It's got some rough spots, that's why it's grabbing my file, but this second pass should be a little bit easier. It's kind of tricky. You gotta make sure you allow the file to follow the groove. And that requires a little bit of dexterity in your part in order to keep the whole thing from getting away from you. And we'll take a look at it. And yes, indeed, I have rounded off those corners a little bit. Now we'll move this over to the mill, and I'll proceed to cut the flutes as I did with the previous one. You've seen that done already, so I'm not going to waste your time, as we need all the time we can take so that I can demonstrate the this very same hob doing two different functions. We're going to cut a worm gear as well as a spur gear. Okay, we're at the mill now, and as you can see, I have the blank chuck to the 3-jaw, which is in turn attached to the dividing head. I also have the slitting blade that I used in the previous hob in order to begin to mill the 10 flutes, as well as mill the relief for the teeth. Now, one method that I use that I did not use in the previous one is to just get a little height gauge, find the center point of the piece that you just turned, and you can tell that because you faced it, and so that has a little mark on it. So once you find that point, adjust your height gauge to that position. You can bring that little point over to the edge of the blade, and we can then lower the blade until that edge has been brought to that point, as we have done here. And that will ensure that the cut is actually offset slightly, and that is what creates the relief that we need in order for the tool to be able to cut. Otherwise it would just rub. Okay, once again, you've seen me do this before, so I'm going to go ahead and do this, and when we next see each other, the spiral hob will be completely milled and ready to be hardened. Okay, and here we have, in all its gorgeous splendor, our newly fabricated spiral hob. You can see how the teeth spiral as I turn it, and basically I situated it about center position between the top and bottom. The very stringent centering procedures that we were using to mill our gears with the previous hob are not really necessary with the spiral hob. You have to just simply center it as close as you can, but it's not necessary, as the teeth will actually be milled automatically as the blank is turned against the spinning cutter. A little bit hard to comprehend until you see it actually working, so let's go ahead and prepare to do that. Now, the setup for this particular milling situations is